Hey everyone, so I'm going to take you through the solutions to the optimization word problem worksheet 4. So again, pretty much the same thing, nothing new on this, just more practice. So closest to the point, oops, turn my pen on, that tells me I'm using the distance formula. So the distance is x2 minus x1 squared, y2 minus y1 squared. So I'm going to plug in, this is my x1 and x2. So x2 plus 3 squared, y2 minus 1 squared. But now I don't really need the x2, it's just going to be x plus 3 squared plus, and then instead of y, remember we need x, only x's in the problem or only y's in the problem. If I solve that, I get y equals 9 minus 6x. So I'm going to substitute this in, 9 minus 6x minus 1. All right, so now that's my function. This is what I'm going to take the derivative of. So the derivative of the square root is 2 times that square root. So I'm going to simplify the inside also. It becomes 8 minus 6x squared. So that's the denominator. And the top is the derivative of the inside. So here's my inside. I just need the derivative of that. So bring the 2 down. And then bring the 2 down here. 8 minus 6x times the derivative of the inside, negative 6. Now, because this is a real-world problem, we really don't have to worry about where the denominator equals 0. So I'm just going to ignore it. We're finding where the top is going to equal 0. So that is 2x plus 6 minus 12 times 8 minus 6x. Set that equals 0. 2x plus 6 minus 96 plus 72x. 74x minus 90. So I got x is, 45 over 37. So that's my x value. And then I'm going to replace that y, 9 minus 6 times 45 over 37. And I got 63 over 37. All right, find the points on the hyperbola, that are closest to the point. So this is another distance formula. It's basically the same exact thing that we just did, but notice it's y squared and x squared. So I'm going to start by plugging into my distance formula, x minus 2 squared plus y minus 0 squared, which is x minus 2 squared plus y squared. So then if you look, what we're going to substitute in, that's the ugliest y squared. I'm going to take the equation and solve for y squared. So that's x squared plus 4. So that's my substitution. I'm going to put that in. So we have x minus 2 squared plus x squared plus 4. That's my distance formula. That's what I'm going to take the derivative of, set equal to 0. So 2 times the square root. Honestly, I don't even write the bottom usually if this was for myself, because I'm going to ignore it anyways. Derivative of the inside goes on top. 2 times x minus 2 plus 2x. I'm going to set the top equal to 0. 2x minus 4 plus 2x. 4x equals 4, so x is 1. If x is 1, then I plug in 1 squared plus 4 is 5. So the square root of 5. Or negative 5, I guess. It doesn't actually matter, I don't think. A rectangular storage container with an open top is to have a volume of 10 meters cubed. The length of the base is twice the width. Material for the base costs $10. Okay, I'm going to start by drawing my picture. rectangular storage container. An open top. All right, my volume, length times width times height is 10. The length of its base is twice the width. So this would be W, this is 2W, and then we have H. So the volume, which is going to be 2W squared H equals 10. So my guess is I'm going to get rid of H and make that 5 over W squared. Without doing anything else, that's my guess. All right, material for the sides cost 6 per square meter. Material for the sides cost $6 per square meter. Find the cost of the material for the cheapest container. Wait, the base is 10. Okay. So the base, that's this. So the area of that, right, we're talking about surface area here, is 2W squared, and that's going to be times $10 plus the four sides, we have 4WH, and that's $6 per square meter. Remember, there's no top. So we've got 20W squared plus 24W, and now I have to get rid of the H, so I'm going to use this, which, I knew I was going to have to do something there. So 20W squared plus, what is that, 70 over W. So that's my surface area formula, and this is what they want me to minimize, because, well, it's cost, really, right? A prime, so 40W, and then 70 over W, 1 over W is negative 1 over W squared, so negative 70 over W squared. So we're going to set this equal to 0. Common denominator, so this becomes 40W cubed, right, because W squared minus 70 over W squared. We're not going to bother setting the bottom equal to 0 because the answer cannot be 0. So we're just going to set the top equal to 0. So let's see, I get 7 over 4 equals W cubed. So W is the cubed root of 7 over 4, whatever that terribleness is. Let's see, find the cost of the materials. Okay, so we're going to plug in here. So I'm just going to plug that in my calculator and see what happens. I got 87.132. Well, 13, I guess, since we're talking money. But in calculus, usually we have 3 decimal points. All right, find the area of the largest rectangle that can be inscribed in a right triangle with legs of length 3 and 4 if 2 sides of the rectangle lie along the legs. All right, this is the hardest problem on this worksheet, in my opinion. So I've got my rectangle. So we are maximizing the area of the rectangle, right? So the area of the rectangle is length times width. So I just named it length and width. But then I also know that this whole thing is 4 and this whole thing is 3. So now here's what's hard about this one. Finding a relationship between the triangle and L and W. So it's not necessarily something you would recognize, but these are similar right triangles. So what I did here was I said this was L, right? If the bottom is L, the top is L. And then I said this is 3 minus W. So that tiny little triangle is in proportion with the big triangle. So 3 over 4 equals, so the whole thing is 3, right? So the little one is 3 minus W, and the bottom is L. Right? So 4 is the whole thing, and then L is the whole thing. So I've got 3L equals 12 minus 4W. So L is 4 minus 4/3 W. So then the area of my rectangle is length, thirds W times W, 4W minus 4/3 W squared. So that is what I'm going to take the derivative of. So it's not that this is hard, but if you've never thought about making that proportion, we did that with related rates, but we've never done that with optimization. So take the derivative, set it equal to 0. So 8/3 W equals 4. W equals 12/8, which is 3/2, 1.5. So that means that the length, find the area of the largest rectangle. All right, so the length would be 4 minus 4/3, 3/2. So 4 minus 2 is 2. Oops, that's a minus. So we got 2. So the area then would be, the length is 2, the width is 3/2, so 3. All right, next one. The top and bottom margins of a poster are each 6 centimeters, and the side margins are 4. So, here's my writing and my margins. So let's see. The top and bottom are 6. So 6 and 6. And my sides are 4. The area of printed material is fixed at 384. So that's my X and my Y. So 384 equals X times Y. Find the dimensions of the poster with the smallest area. So the poster, the area of the whole thing would be X plus 8 and Y plus 12. And then I have to substitute in. I always solve for Y. Doesn't really matter though. 384 over X. So X plus 8. And then 384 over X and plus 2. That's my area. So now I'm going to minimize that. So take the derivative. It's a product rule. If you want to multifoil it out first, go for it. I don't do that, but you can if you want. Derivative of the first is 1. So 384 over X plus 2. And then plus the first derivative of the second. So that is negative 384 over X squared. Set that equal to 0. Let's see. Ooh, I'm going to move that. What's the easiest way to do this? So 384x plus 2x squared over x squared. And then minus 384x minus whatever that is, 384 times 8, 3072. All right, combine like terms, set it equal to 0, ignore the bottom. So the 384s go away, so we get 2x squared. Is that plus 3072? That doesn't make sense. No, it's minus. I messed the negative up. This is supposed to be a plus, because the minus, I brought this minus to the outside, so this is minus. So x squared equals 1536. X is the square root of 1536. Is that a real number? Nope, that's a decimal. 39.192. Find the dimensions of the poster. So that's our x. is 39.192, and our y will be 384 divided by that, which is 9.798. And that's our answer. All right, number 6. Find an equation of the line through the point 3, 5 that cuts off the least area from the first quadrant. All right, 1, 2, 3, 1, 2, 3, 4, 5. So here's our point. So this needs to cut off from the first quadrant. So it's going to be something like that, right? So what do we know? Think about what you know here. So the equation of that line is y minus 5 equals m times x minus 3. Okay, so then we also know that we want an area, right? The area of the first quadrant. So that's area of a triangle, 1/2 x times y. And notice that the x and the y are really the x-intercepts and y-intercept. So what I'm going to do is I'm going to solve for the x-intercept in this equation, right? The x and the y. So if I let y equals 0, 0 equals -5, 0 minus 5 equals m times x minus 3. So again, we're solving for x. So that's mx minus 3m equals -5. So x equals, we get 3m minus 5 all over m. Right? And then I'm going to do the same thing, but solve for y. So y minus 5 equals m times 0 minus 3. Y minus 5 is -3m. So y is -3m plus 5. So now I have a substitution for x and y in terms of m. So that's 1/2 3m minus 5 all over m, and then -3m plus 5. So that's my area. So now this is what I have to take the derivative of. I'm trying to think how I did this. I did this a while ago. I think I multiplied it all out first because it's a quotient rule. I didn't want to do a quotient and a product rule. So I think what I did was I took that negative out, made this a minus. So that's 9m squared minus 30m plus 25 all over 2m. And then I did a quotient rule. Or did I? No, I didn't. I think I did -9 over 2m plus 15 minus 25 over 2m. Alright, I think that's what I did. I'm trying to think of the easiest way to do it. There's lots of ways we could do this, though. Alright, I'm going to take the derivative. Plus 25 over 2m squared. Set it equal to 0. So m squared. So we get 0 equals 25 minus 9m squared. So m is plus or minus 5 over 3. Now, since this has to be a negative slope, so I know that my m is going to be -5 over 3 for that to make sense. So y minus 5 equals -5 over 3, x minus 3. And that's the answer. A little tricky. Alright, during the summer months, Terry makes and sells necklaces at the beach. Last summer, he sold necklaces for $10 each, and his sales averaged 20 a day. When he increased the price by $1, he found that he lost 2 sales per day. If the material for each necklace costs $6, what should the selling price be to maximize profit? So his profit equals, so I'm going to let X equals the change in price. So he sold for $10, but $6 to make it. So I'm gonna go with 4. So he's selling he's making $4 plus an extra dollar for every price change, and then he's losing 20 per day. So then 20. Sorry, he's losing. He found he lost 2 sales per day. So he's starting with 20. He's losing 2 per day. So the $4 is the profit. He was selling them at 10, but it took him $6. So $4 plus whatever the increase is, and then he was averaging 20 and then losing 2 per day, 2 per change in price. So that's your equation. Take the derivative. That's the hard part. The rest of this should be easy. Derivative of the first is 1 times the second plus the first. Derivative of the second. Yeah, these are pretty easy if you can figure out the equation. So let's see, we get 4x equals 12, x equals 3. So his selling price should be $13. All right, what is the area of the largest rectangle with sides parallel to the coordinate axis that can be inscribed in the ellipse? All right, so we have we have an ellipse. I don't remember what this looks like. The largest rectangle that can go inside of it. Again, these are always symmetric. So this is x and this is x, right? And then, so the area would be 2x times, what is this distance? So now this is a little tricky. I'm going to solve for y. So y is the square root of 16 minus 4x squared. So this would be this distance, but we need to double it because we need the part down there. So it's going to be 2 times that square root, right? This red piece up here, again, is that square root of 16 minus 4x squared. If I haven't convinced you, you can always plug it in your calculator. And then we need to double it because of the symmetry for the bottom piece. So 16 minus 4x squared. I'm going to simplify that. 4x, the square root of 16 minus 4x squared. Take the derivative, set it equal to 0. Derivative of the first times the second. The first derivative of the square root, 2 times the square root. Derivative of the inside goes on top, negative 8x. So, set it equal to 0. I'm going to simplify that 2 out. It becomes a 2. So, minus 16x squared over that square root. Common denominator. So, we're going to multiply this left one times that square root, which ends up squaring this. So we get 4 times 16 minus 4x squared minus 16x squared. I'm going to ignore the bottom. Like I've said before, we're not going to set the bottom equal to 0 in a real world problem. You end up getting like something that'll make the area 0. So 64 minus 16x squared minus 16x squared. So we end up getting 32x squared equals 64. So x squared is 2. X is the square root of 2. What is the area of the largest rectangle? So if you want, you can go back up here to get the actual area, or you can plug into the original. Let's see what we get. So I'm going to go 4 root 2 times the square root 16 minus, I think think that's an 8. 2 times 4 is 8, yeah. So this is, I think you get 16. Because that becomes 4 root 2. I'm running out of space, times root 8. That's the square root of 16. 4 times 4 is 16. Yep, 16. All right, next one. A closed cylindrical aluminum can has a volume of 16 pi. Find the dimensions of the can that minimizes the amount of aluminum used. A closed cylindrical aluminum can. So we're talking surface area. Right? Volume is 16 pi. I think when I typed this, I couldn't find a good pi. Like, they all looked weird. So the volume of a cylinder is pi r squared h. So it's a lot easier to solve for h. Nicely, the pi's go away. So h is 16 over r squared. So we're talking surface area. Surface area, there's 2 circles. So 2 pi r squared. And then the distance around is cylinder, right? Circumference times height, right? Circumference is 2 pi r, and then h for the height. Substitute in for h, so 2 pi r squared plus 2 pi r, 16 over r squared. I'm going to simplify that, 2 pi r squared plus 32 pi all over r. Alright, so that's my surface area. Take the derivative, set it equal to 0. 4 pi r minus 32 pi over r squared. I'm going to make my common denominator, so times r squared. So 4 pi r cubed minus 32 pi all over r squared. Again, I'm going to ignore the bottom, set the top equal to 0. So 4 pi r cubed minus 32 pi equals 0. So r cubed, it looks like, equals 8. Right? 32 pi over 4 pi is 8. So r is 2. If r is 2, h is 16 over 4, which is 4. This is definitely a no calculator problem. That was easy. All right, last one. A wire 35 centimeters long is cut into 2 pieces. So this is the exact same. I just made this up because I wanted you guys to practice. So this whole thing is 35. This is x, and then we have 35 minus x, right? So remember, those are the perimeter, right? So we have an equilateral triangle, right, is, pick a letter, A, whatever you want to call it, right? So 3a equals x. And then we have our circle, pi r squared, 2 pi r, circumference, equals 35 minus x. So in both cases, we're solving for the sides in terms of x. We want x in our problem. How should the wire be cut so that the area is a minimum? So now here's the tricky part. Who knows what the area of a equilateral triangle is? So if you think back to trig, its area is 1/2 AB sine of C, but it's 60 degrees in an equilateral triangle, so that's root 3 over 2. So you've got 1/2 root 3 over 2 times a squared, x over 3 squared, plus pi r squared. So those are your areas. So it's a little tricky, I would say. Let's see what we get. We get square root of 3 over, that's 4, and then 3 squared is 36, x squared, plus one of the pi's goes away. 35 minus x squared over 4 pi. Because we have to square the 2. So that's my area. That's what I'm going to take the derivative of. Root 3 over 18x minus 2 times 35 minus x over 4 pi. So the minus came from the derivative of the inside. Ugh, I'm running out of space. Okay. I think the easiest way to do this. So 0 equals root 3 over 18x minus 70 plus 2x, 4 pi, 4 pi. This one's kind of gross. So what I did was I moved the 70 over 4 pi over, and then I factored out the x, root 3 over 18 plus 1 over 2 pi. And then it really just depends on, like, what is this a calculator problem, a no calculator problem? So I think I just wrote it like this. And then I plugged it in the calculator or something. I don't know. This one's like, it's super gross. If you use a calculator, it's not bad, but that's what I got for my answer. So I got 21.812. So that's pretty gross. And then 13.188. So those are my 2 answers. All right, that's it. Don't freak out. There's only one of these on the test. It'll be okay.